Now, as I was saying, that this particular slide holds a very important place. Why is it that I am repeating this concept even after we have already had a overview about this in the pre-press repro class? Now, see, I have always said uh, to all of you that the image quality is system dependent. Here, the image that you can see on your left, the image with the flower and all the leaves over here, uh, uh, this is the image that you want to reproduce, let us say. Now, you have got a camera, you've got a TV, a digital display, I mean, you have got an offset printer and an inkjet printer. Now, we have developed this much idea till now that the quality, if you want to reproduce the same image, that is the image with the flower and the leaves, if you want to um, you know kind of reproduce that using all these four technologies, the ultimate output that you will be able to get is different in different technologies. Why? Because the method of reproduction of image in all these four technologies are different. So here, if you take a look, that if you are considering a conventional film based camera, how does a film based camera reproduce? It reproduces the image with the help of a silver halide crystals. The areas which are exposed by light within the film, there the silver halide will be reduced to metallic silver. This metallic silver, wherever deposited, will lead to the formation of the image. Then we have got this digital display. This let us say this is a LED panel. Now, how is the image being reproduced over here? There are multiple, numerous pixels with spread throughout the entire image. Even the device that you are watching this video right now, you may be watching this video on your mobile phone, on your computer, your laptop, whatever. In all those devices, there is a array of these pixels containing red, green, blue sensors uh, spread throughout the entire display. So whenever there is a information that this area, for example, this in this particular area, all the red pixels are lit up. In this area, in this particular area, all the green pixels are lit up. So like this, the image is being reproduced. Now, the pixel density, what we refer to as the resolution of the screen, that is represented in PPI, that is pixels per inch. PPI. In the screen, in halftone screens, how did we represent their resolution? We represented their resolution as LPI, that is lines per inch, right? In the digital displays, we have got resolutions, the unit using which we can measure the resolution is PPI, that is pixel per inch. So greater the pixel per inch or greater the resolution, better is the image quality. Now you have got this 4K, 8K displays. That means what? In 4K displays, there are a total, I think, some 4000 by 300, 3000 something pixels spread along the length and the breadth respectively of the entire digital screen. So this is what the kind of resolution is, or this is what drives the quality of the image. Okay, then you have got the offset technology. What is the main fundamental imaging unit in offset technology? It is what? It is halftone dot. Wherever there is a halftone dot, ink will fall over here, and rest of the areas ink will not fall. Right now, conglomeration of those dots, big and small, greater number, lower number, such conglomerations lead to the creation of a particular image. Okay, in case of this inkjet technology, how does it create images? They create images somewhat similar to the offset technology, but the dots that are used over in inkjet technology, they are known as deterred dots, and the screening technique is known as dethering, and the dots are known as deterred dots. In case of offset printing, the screening technique is known as half toning, right? In case of deterred, inkjet printers or any digital printers for that matter, the technique is known as dethering, and the dots are known as deterred dots. Okay, so these are the different types of different methods of creating discretizing the image for the purposes of image reproduction. So your film based camera discretizes the entire image in some form of metallic silver wherever it is, deposit metallic silvers are deposited, there will be image formation. But in case of film based camera or films, we call those images as continuous because there is no such process of discretization for that matter, right? As you know, there is a form of discretization in half tones, I mean offset printers, or discretization in your inkjet printers. In case of your film based imaging systems, there is no such discretization thing. Film-based imaging systems, I mean only cameras, film-based cameras, those, not the image setters that I referred to. They discretize. They need to half-tone the image to create films that have got half-tone dots using which we can create plates and ultimately to print. Okay, so this is what the difference is in quality of the same image when they are reproduced using different reproduction techniques. Only your film based images are known as continuous tone, rest everything is known as discretized. The names are different, right? For offset it is half tone image, for inkjet it is deterred images. Alright, so that is what I mean when I say that image quality is system dependent. You already know, just a recap of the earlier one. Okay, next. So this is, I already explained how this is a basic type of working principle of how images are being reproduced using your in your LED technology basically. Okay, or digital displays. There is a series of these color filters or these pixels, and whenever this certain the LEDs of a certain area is lit up, depending upon the information received, some of the pixels, for example over here, the red pixels will be lit up. In this area, the green pixels will be lit up like this. Alright, next. So this is again, so for example, this is a very close up view of a digital screen. As you can see, there is a, each pixel has got three, or a set of three sensors, that is individually this is one pixel, this is another pixel, like this. Okay, so each of the pixel has got three sensors, red, green and blue sensors. Depending upon the information available, all of them are lit up. Okay, and ultimately we will be seeing the image depending upon which pixels in which locations are lit up. All right, now let us come to the very important topic, which is known as uh, where we will be dealing with the different types of classification of graphics. Okay, so if I ask you that what is the basic difference that you are seeing between the image that is present on your left and that is present in comparison to the image that is present on your right, what is the basic difference? Just pause the video here for a minute and try to answer the question yourself. What is the basic difference? See, on the image that is on the left hand side, this is sometimes we refer colloquially as this is pixelated, right? This is not that clear. But the image on your right hand side, it is very much clear. That means the quality of image is different. This is the basic difference. On the image that you see on the left hand side, this is not having that good a quality. But the image that you see on the right hand side is having very good quality. Now, why this might be the question, right? What is the answer to this question? Again, I will show you another picture of the same image. This was also of the same image. This is also the same image. On the A that you see on the left hand side of the image of the screen, this is again something which is known as pixel. I will tell you the actual or the accurate term for that is to be used for this type of images. But what is the basic difference between this type of image, that is one on the left and one on the right? The basic difference is that the one on the left, as you can see, is kind of pixelated, right? Now if it is pixelated, what does it mean? The quality will again go down. That means the quality is not that great for the image on the left. But the A on the right hand side is quite clearly visible. Even the edges of that A is quite clearly visible. There is no distortion for that matter. That is what I mean when I say it is pixelated. Now, why is this happening? Let us understand that in the first place. So now let us try to understand that why is it that some of the images that I have shown you is getting distorted in quality and some of them are not. Let us try to analyze that. You see, from here on, whatever I'm talking about, you will be understanding, or you will be or whatever we are discussing, this is how we differ, or how we differentiate rather, object based images and pixel based images, which we sometimes colloquially call as vector based images and raster based images. But we will not use those vector and raster terms. We'll be using object based and pixel based. Now see, there is kind of a interesting story behind these object based images and how they were created in the first place. uh, if I remember correctly, then there was a person known as Pierre Bezier. He was working with the Renault car company. You've heard the French car making company Renault. So he was there in, I think, the design team or something, and they were trying to design an automobile. Okay, and during that time itself, he created these curves. These curves are based on the Bernstein polynomials, and this was, I think, in the 1960s or something. And just to create the shape of the bodywork of the curve, those that appear in the cars, he created these type of curves. Now, the interesting fact about these curves are why I am talking about curves while talking about images and graphics, that you have to understand. But first, let us try to understand that what are these curves all about, how these curves help creating this image, I mean these graphics, and what is the primary difference between these curves and the images that we see. These curves, because they are polynomial equations, so they are driven by polynomial equations, they are very precise and they are scale independent. Why am I saying all this? Why am I saying they are scale independent? Because ultimately, let us say you are trying to draw a circle. You can increase the radius of the circle and you can increase the size of the. Will there be any distortion in that? No, there will not be any major distortion in that shape of the circle or the boundary of the circle. Similarly, if you are drawing these type of curves, will there be any distortion in this type of in the shape or the quality of this type of curves? No, there will not be. I will show you one example why there is no such distortion. I think I have got a picture over here. Yes, take a look at the picture. Don't get afraid by the maths, whatever you see. We'll be talking about the maths a little bit, but later on, when we are talking about fonts, the fonts are also derived from these curves itself. Okay, outline fonts and this PS one, they're derived from these curves itself. So try to take a look at the curve that you see in front of you, right? This is a particular curve, this one, this, that is the continuous black line, okay, starting at b0 ending at b3. Okay, these are the terminal points. Okay, these are the terminal points. Okay, that is b0 and b3, right? And there are two points, additionally two points, that is b1 and b2. These are known as the control points. These are known as the control points. Okay, so what does this control points and what is the difference between the terminal points and the control points really? Let us understand that. You see, let me draw another type of a curve. Let us try to understand from that point. Let us say this is one curve A and this is one point A, another point B. Now, if I want to join these 2 points using a single curve, how can I do it? Without any control points, I can simply draw a line, straight line, that is between a straight line between 2 points, right? So we can call this to be a curve, but this is not really a curve, this is a straight line, we can say. Now, in order to make this a curve, what do I need to do? In order to change the shape of this line, not the curve really, in order to change the shape of this line, what is the minimum condition that I need to fulfill? Or if I want to convert this straight line into a curve, what is the minimum condition that I need to fulfill? I need to introduce a minimum of one point using which I can pull or push this curve. Okay, let us say I have introduced one point in the middle. Let us say this point is C. Okay, now I am from this point. I think for people who are working with Illustrator, they have a fair bit of idea about how to introduce anchor points and how to change the polygons. I will come to the concept of those uh, as I go ahead with this lecture. But let us try to change the shape of this line about this point C. Now let us say I have introduced one point C, which I am calling it to be a control point. Now why it is control point? Let us try to analyze it. Now what will happen? What will happen to the shape of this straight line if from this control point I pull this control point downwards? What will happen to the shape? The straight line will no longer be a straight line. It will become something like this, a concave type of a curve. Okay. Now, on the contrary, if I try to pull this point upwards in this direction, what will happen to the shape of the straight line? It will become a convex type of a curve, right? This is how Bezier curves are created. Ultimately, these are all polynomials, right? Which is guided by this one. Boundary conditions are given. These boundary conditions are have to be maintained in order to create the terminal points for the curve. But nonetheless, I am not going to the mathematics of it. But let us try to understand one important thing, that what is the function of this control point. Without this control point, we cannot manipulate the curve. So let us say we want to draw the shape of a or the character or the letter C. Okay. So how to do that? Let us say there is another 2 points, A and B. Okay, these are the 2 points. I'm drawing a straight line. Now, if from this straight line I want to create the character C, then what you have to do? I have to include another control point over here, and I have to pull this straight line along this control point in this direction. What will happen? This will appear to be like this. This is looking almost as C, right? But in order to create a perfect amount of a perfect shape of C, we need multiple additional control points throughout the surface to get that perfect kind of appearance of that character C, right? Now, because these are polynomials, there are grades of polynomials, there are degrees of these polynomials. If we are using a single control point, as in this particular case, or as in this particular case, these are known as, the degree is quadratic. These are known as quadratic Bezier curves. Okay, but there are certain cases where we need to introduce more than one. For example, this one, how many control points are there? 2. Because there are 2 control points, see, the initially without any control point between this boundary condition, the line would have been, the shape of the curve would have been a straight line like this. Because we have introduced 2 different control points and we have pulled these control points in 2 different directions, one in this upward direction, one in lower direction. That is why this is appearing to be like a wavy structure or wavy type of a curve. These type of curves with higher degree of or higher number of control points, where we have used 2 control points, these are known as cubic Bezier curves. Okay, and we can go on increasing the degree and complexity depending upon our requirement. Now, the basic idea of the Bezier curve is clear. Now, what we are doing, essentially what are we doing? We are just creating some mathematical functions, and just let us say that what is the mathematical function that defines, I'm very simply I'm putting, what is the mathematical function that defines a shape of a circle, x square plus y square equal to r square. This is what. Now let us say with this you can draw for any value of r, you can draw a particular circle of a given r value, radius. What is going to happen if I go on increasing the r value? The circle will get bigger and bigger. But will there be any distortion in the shape of the circle? No. Why? It is purely driven by some polynomial or some mathematical equation. Okay, this is the precise reason why graphics which are created with the help of these Bezier curves, they are kind of scale independent. That means you go on increasing the size of the objects, the scale will not, the image will not get distorted, or the image will not get pixelated, so to say, actually. Okay, but on the other hand, if you take a look on the image, that is the pixel based image, this is a pixel based image, in both the case we want to write the letter E. Okay, In this case, in this particular case, we are using these Bezier curves with multiple control points throughout the throughout the area. Okay. Now, depending upon the size of the letter E that we want to we want to create, we can change the shape of the or the position of the control points, and we can enlarge it or squeeze it down without any change in the shape or without any distortion in the quality of the image. But in case of a pixel based image, how does it occur? A pixel based image works on the principle of that matrix that I told about. These are the various pixels that you see on the screen. And pixel based images are created by filling up or lighting up certain pixels in certain areas. This, if you are creating a letter E with a pixel based software, then that E will be a conglomeration or a combination of various uh, pixels. Areas or the pixels of certain areas will be lit up. This will be lit up, this will be lit up, this will be lit up, and this won't be lit up. They will not be lit up. So ultimately, together you can get the shape of the letter E. But what is going to happen if you increase the size of the, or if you increase the size of E, or if you just visualize this image in a high resolution screen? What will happen? It will all get pixelated like this. See what is going to happen. On the edges, you see, a pixel cannot be partially lit up. A pixel is either fully lit up or not lit up. Okay. So let us say in this area, this pixel will be lit up, this pixel will be lit up, but this pixel will not be lit up. Ultimately, what is going to happen? The tail of the letter E is going to go missing. This type of jagged edges, this is known as jagged edge appearance, or aliased appearance. Jagged edge or aliased appearance will occur. That means the entire image will get distorted. This is the fundamental difference between an object based image and a pixel based image. One is created with the help of a few curves, and the other is created with lighting up these pixels. And as we know, the pixels are not partially lit up. Some pixels will light up, some pixels won't. And ultimately, this type of staircasing, another name, staircasing effect. You see, staircasing effect almost looks like a staircase. So this is also known as staircasing effect. Staircasing effect, jagged edge, aliased effect. These are all names of the same thing. That means it will be uneven, very rough surface. But in case of this E that is created with the help of object based or objects here means those Bezier curves. They will actually appear to be very much smooth around the edges, and they will be scalable. That means scale independent. You go on increasing the size, you go on increasing the font size, it will not change. So from this information, what inference can you draw? Whenever you are trying to create, that means in the, if you go back in this particular case, whenever you are trying to create a logo, for example, our college logo for that matter, or this logo that I am showing you, this must be created with the help of these objects or these Bezier curves using software like Inkscape or Illustrators. You go on increasing the size of the logo, you go on reducing the size, there will be no visible changes. But if you create the same logo using a pixel based software like Photoshop or GIMP, then as soon as you change the resolution of the screen or you enlarge it, it will all get this jagged appearance, this staircasing. See again, staircasing effect. Staircasing effect is occurring. This is, the quality is deteriorated. That is why when we are editing images like photographs, we have clicked a photograph using our phone camera or a digital camera, we'll be using a raster based image editing software like GIMP, like Photoshop, because as an image cannot be vectorized. I mean, for a lack of a better term, yes, vectorized. That means it cannot be converted into those objects because it is almost like a continuous tone image. But this object based images, they need to be scalable. They need to increase in size or decrease in size without deterioration of the quality. That is why we are using this Illustrator software or Inkscape software to create these type of graphics with the help of Bezier curves objects. Okay, Same thing with the A also. Now, so from this information, what inference can you draw? What advantage, disadvantages can you draw? Object graphics, they are made up solely of some curves and lines. And of course, they are scalable, right? So what are some of the advantages of these type of graphics, object graphics? They can contain unlimited number of colors. Every block, every curve can have a different color. And they can be rescaled. That is scale independent, I have already told. They are easy to, if you're using the correct software, then they are very easy to edit. And most importantly, because they are derived using some mathematical formulas, mathematical equations, they do not take up a lot of memory. But one disadvantage is also there, that if you're editing, if you're choosing a object based graphic software to edit a image or a photograph, that cannot be done, because the nature of the image, both the images are different from each other. Okay, so this I have already told you. And the greater, see, greater the number of control points, one thing that over here, see, the number of control points, they are referring to as anchor points in Photoshop. I mean, this Illustrator also has this term anchor point. It essentially means the same. Greater the number of control points, more smooth the curve will appear to be. If you compare this curve and this curve, which is smoother? Obviously the one on the top, this one. What is the difference? Because in this, the lower segment, the number of control point is low. Here the number of control point is high. That is why it's appearing to be very smooth in nature. That is another important point regarding the object based graphics. Greater the control point, number of control point, greater will be the quality. The smoother will be the appearance. Okay. Here, now, because you see another, I just want to give you a very brief idea about what this is. Now these type of Bezier curves, they can be combined together to form Bezier splines, or they can, if you are using these Bezier curves in higher dimensions, because they are polynomial, they are higher dimension or higher degrees of polynomials if you are introducing into your artworks, then you can create what is known as the Bezier surfaces. In Illustrator, if you are familiar with it, there are certain terms like mesh, right? So this mesh type of appearance, these are higher degree polynomials. Essentially they are the same, they are Bezier curves only, but they have been combined together. Multiple such curves of higher degrees have been combined together to create these surfaces. There were control points earlier, these are the control points, and here you have got control surfaces. That is the only difference. Okay, so that means what? You are able to, for example, with the right software and with the right skill, it is possible to edit your photograph. That is, this is a photograph or an image. You are able to edit that, or you are able to convert that into vector or object based graphics also. All right, so that is what the basic difference between pixel based graphics and pixel based images and object based graphics are. Okay, another one example I want to show you over here. You see, now uh, here you see, this is a kind of a signature. Now this is a line art. Signature means it is going to be a line art. Here the resolution is very low. That is why this jagged appearance is occurring. The staircasing effect is occurring, as we can see along the edges and all. If you convert this into your objects, then the ultimate result that you are going to get is much more smoother. But on the contrary, this is a line art. That means this is, I mean, similar to a logo, right? But in this case, this is a photograph, an image for that matter. Here, if you want to convert this into a, using Illustrator into a object based image, then you have to use those surfaces like I showed you in the previous image. These surfaces, the result is something different. It appears to be posterized, you know, in the this in I think print design we will be talking about this posters and this pop art type of things. Appearance is something different because there are not enough control surfaces. So let us see, let us take an example. Whatever this is, maybe this is some pudding or something. See, the top of the pudding is having a darker appearance in comparison to the sides, but as soon as you convert it into your object based graphics, what happens, there are not enough control surfaces and the color of the top as well as the side almost becomes the same. See the structure of the leaf over here, see how it has been distorted. So that means you have to be careful not to convert everything into object based graphics just because it is scalable and just because it can do certain things. You have to choose your subjects carefully. If you are working with a logo, if you're working with a line art, of course you need to convert it into object based graphics to improve the quality. But if you're working with photographs, never. Even if it's not never, very carefully you have to choose very carefully which photograph you can rasterize, I mean which you can convert into object based graphics and which you cannot, or which you need not convert. All right, now let us talk a little bit about the pixel based graphics also. What are the uh, kind of uh, opportunities and the various disadvantages that they provide? As you can see, the pixel graphic is divided into tiny squares of color, that is known as pixels. Individual pixels are lit up with certain colors, right? Now they can be created in various different ways. One, you can directly scan from a continuous tone photograph. It may be a film scanner or a hard copy reflective type scanner, right? You can click an image with the help of a digital camera, and you can directly use those types of pixel based images. Here I think I have written the term graphics, but it is better to distinguish between the term images and graphics. I'll tell you why. And the third point is, I was talking about, that you can create those in these Corel painters and Photoshops, etc. Why I am saying this different, these different terminologies, that it is very important for you to distinguish between these two terms. That is, whenever you are talking about pixel based, you refer the term as images, pixel based images. But whenever you are talking about object based, you refer the term as your graphics, so that you draw a distinction between the term image and graphics. You immediately realize when I'm saying the word image, that means definitely it is a pixel based image, and whenever I'm using the term graphics, it is a object based word. Okay, so hopefully this difference and the basic idea about the prepress technology is clear to you. All right, thank you, and we'll be meeting in the next lecture to discuss about some other terminologies like color modes and most importantly bit depth. Okay, thank you.